trigonometric ratios of special angles. So the special angles we refer to are 45-degree angle, 60-degree angle, and 30-degree angle. And the trigonometric ratios that we speak about are the ratios of the sides, and we have names for them. We call them the sine function or sine, cosine, tangent, and their reciprocals, cosecant, secant, and cotangent. So in this video, we will derive the trigonometric ratios for a 45-degree angle. So let's say, for example, we have a right triangle that contains a 45-degree angle. What is the measure of angle C? Well, it's equal to 180 minus 90 minus 45. It's equal to 45 degrees. Why so? Well, because the sum of the interior angles of any triangle is 180. And since we already know that angle B is 90 and angle alpha is 45 degrees, so this means that angle C is a 45-degree angle. Well, this means that this right triangle is a special kind of right triangle. It is an isosceles triangle. An isosceles triangle is a triangle that contains exactly two congruent angles. I know you are not used to seeing an isosceles triangle drawn in this way. Usually your teachers will draw it in this way. Okay, so the vertex angle is at the top. That is your vertex angle, and the base angles are drawn at the bottom. But this is an isosceles triangle. Now, isosceles triangles have another important property, and that is it has exactly two congruent legs. And those two congruent legs are the legs that contain your vertex angle. Okay? Let us obtain the length of side B. Side B is your hypotenuse. The hypotenuse is the side of your triangle that is opposite. That is opposite your right angle. So what then is the length of B? B is equal to the square root of that, and that is equal to the square root of 2 times A. That is the length of our side B. So we are now prepared to obtain the ratio of the sides of your right triangle. And these ratios, by the way, have names. We call them sine, cosine, tangent, cotangent, cosecant, secant. So we have these mnemonics to help us remember the ratios of an angle that is 45 degrees. S there stands for sine. O is the side opposite the angle. H is the hypotenuse. C is for cosine. A is for side adjacent. T is for tangent. Okay? So what now is sine of alpha? Okay, alpha is 45 degrees. Sine of alpha is so. So that is equal to the side opposite alpha, that's A, divided by our hypotenuse. The hypotenuse is the side that is facing the right angle. So A divided by A is equal to 1. This is equal to 1 over square root of 2, and it is equal to square root of 2 divided by 2. So some students have difficulty figuring out why this one became this one. Okay, so what we did here is we rationalized the denominator. When you say rationalize the denominator, what we mean is we produce an equivalent fraction wherein the denominator is a rational number. But this one is not a rational number. It is an irrational number. Okay, so we multiply by square root of 2 over square root of 2. And that is equal to How about cosine? What is cosine of 45 degrees? Ka. Side adjacent. Okay. So the side adjacent to our alpha is this one. It's A divided by the hypotenuse. So that's going to be also square root of 2 over 2. What about tangent? What is tangent of 45 degrees? So we shall use TOA. TOA. The side opposite our angle, it's A divided by the side that is adjacent, which is also A. So it's equal to A over A. Tangent of 45 degrees is equal to 1. So of course, you know that we have another set of trigonometric ratios for your right triangle. And these are the reciprocal of sine, cosine, and tangent. So what you do is you just obtain the reciprocal of sine function. So cosecant of 45 degrees is equal to the reciprocal of sine of 45 degrees. 2 over square root of 2. And then again, we rationalize the denominator and for the second function, secant is the reciprocal of 1 over cosine of 45 degrees. The reciprocal of your tangent is cotangent.